Is this what makes us fat as we age? You know the feeling, right? You hit your 40s, maybe 50s, and suddenly that spare tire around your middle seems to appear out of nowhere, even if you haven't changed your diet or exercise much. We've always chalked it up to a slowing metabolism, just part of getting older. We figured our existing fat cells were just getting bigger, plumper. But what if that's not the whole story? What if your body actively starts building new fat factories right there in your belly, specifically during middle age? That's exactly what groundbreaking research published just yesterday, April 25th, 2025, suggests. Scientists at City of Hope and UCLA have found something completely unexpected, a brand new type of stem cell that wakes up in middle age, seemingly with one job, to make more belly fat. They're calling them CPAs, short for committed preadipocytes, age-specific. Think of them like cellular sleeper agents hiding in your fat tissue. They lie low when you're young, but as you hit middle age, around 12 months old in the mice they studied, which lines up with human midlife, these CPAs suddenly get an activation signal. And unlike most other stem cells in your body, which tend to slow down and become less effective as we age, these CPAs do the opposite. They kick into high gear. They start dividing rapidly and turning into brand new, mature fat cells, specifically in the visceral fat area. That's the dangerous belly fat packed around your organs. How did they figure this out? It's pretty clever. They took these fat stem cells from older mice and put them into young mice. Boom! Those older cells went crazy, producing a colossal amount of new fat. But when they put young stem cells into older mice, not much happened. This proved it wasn't just the older environment causing it. The cells themselves had changed, becoming hyperactive fat producers in middle age. Using fancy techniques like single-cell sequencing, they could see this distinct population of CPA cells emerge. And using lineage tracing, they watched in real time as these cells built new fat tissue. In middle-aged mice, they found that over 80% of the fat cells in their belly fat were newly generated. This wasn't just minor turnover. It was a massive wave of new fat cell creation. And crucially, they found these same types of CPA cells in human fat tissue too. Guess what? Middle-aged humans had significantly more of these active fat-making stem cells compared to younger folks. So this isn't just a mouse thing. It looks like we have these age-activated fat generators too. So what's flipping the switch? What tells these CPAs to wake up and start churning out fat? The researchers pinpointed a specific molecular signal, the leukemia inhibitory factor receptor pathway, or LIFR for short. Here's the kicker. LIFAR signaling wasn't really essential for making fat cells in young mice. They could do it just fine without relying heavily on this pathway. But in middle-aged mice, LIFR became absolutely critical. Without the LIFR signal, the CPAs couldn't multiply and mature into new fat cells nearly as effectively. It's like LIFAR is a key that only becomes necessary to unlock this specific fat-making program in middle age. This completely flips the script on why we gain belly fat as we get older. For decades, the story was mostly about hypertrophy, existing fat cells just swelling up. Now we know hyperplasia, the creation of new fat cells, driven by these specific CPAs and switched on by LIFR, is a major player, especially for that dangerous visceral fat. It's not just bigger cells, it's more cells. Why does this matter so much? Because that visceral belly fat isn't just about looks. It's strongly linked to serious health problems, type 2 diabetes, heart disease, metabolic syndrome. It pumps out inflammatory signals, messes with insulin sensitivity, and basically accelerates aging. By discovering the specific cells, CPAs, and the switch, LIFR, responsible for building this harmful fat in middle age, we suddenly have brand new targets. Imagine therapies that could specifically tell these CPAs to stay dormant, or drugs that block that LIFR signal only in fat tissue during middle age. We might be able to prevent or slow down that middle age spread at its source. The goal isn't just weight loss, it's preventing the accumulation of the most metabolically dangerous type of fat, helping us stay healthier for longer, extending our health span. Of course, there's still a lot to figure out. What exactly triggers the LIFR signal in middle age? Hormones? Low-grade inflammation? Can we target these cells without causing side effects elsewhere, since LIFR is involved in other body processes? These are the next big questions. But the discovery itself is fascinating, isn't it? It challenges our whole idea of aging as just a slow decline. Here we have stem cells that get more active, going rogue to build fat. It provides a real biological answer to that frustrating, common experience of gaining belly fat no matter what you do. It gives a name, CPAs, to the culprit. It's like finding out there's a hidden factory in your body that switches on automatically in midlife, specifically to expand your waistline. So is our biology programmed to make us gain fat as we enter the second half of life? Or, now that we understand the mechanism, can we finally learn to override the program? Stick around for more deep research into the discoveries shaking up our understanding of health, aging, and the very code of life itself.